In this type 1 of problems, I will demonstrate you the block over block problems, or which is also called as two block problems. So in the first case, I am taking a block of 4 kg and a block of 2 kg which is placed over 4 kg, and both the surfaces are frictionless. There is a force of 12 Newton which is acting on 4 kg block, and we have to find out the accelerations of these two blocks in horizontal directions. So first of all, as the applied force is acting on 4 kg and both the surfaces of 4 kg, upward surface and downward surface, are frictionless, so there is no opposing force on 4 kg, and hence this 4 kg will move with an acceleration of A is equal to F upon m, and its force is 12 Newton and its mass is 4 kg, so its acceleration will be 3 meters per second square. And there is no force which will move this 2 kg block, as this 2 kg block is placed on a frictionless surface. So the acceleration of 2 kg block will be 0, and they will move such that this 4 kg block will move between this 2 kg block and this surface, and this 2 kg block will remain at its position, and when the 4 kg block will move away from this 2 kg block, then it will fall down on the ground. Now let's move on the next question. In this case, second case, there is a friction rough surface under the 4 kg block, and in this case we should write down the maximum possible value which can act on 4 kg, maximum value of friction. So it would be mu into normal reaction. Now it is very important to note that the normal reaction at this surface will be N equal to 60 newtons, which means 6G, because the normal reaction will be due to both the blocks, 2 kg and 4 kg. So the N will be equal to 60 newtons, and therefore the maximum possible value of the friction on the ground will be 0.2 into 60. So it would be 12 Newton of maximum friction that can act on the block of 4 kg from the ground. Okay, so first of all, in these kind of questions, you should find out the maximum possible friction which can act at all the surfaces. Okay, now we can see that the surface of 4 kg is frictionless, hence the 2 kg will again not experience any force which will move this 2 kg block, and therefore the acceleration of this 2 kg block will be 0. We can directly conclude this. And the other important thing is the fact that this force is 12 Newton which we are applying on 4 kg block, and the maximum friction which can restrict the 4 kg block is also 12 Newton. So this friction is sufficient to prevent sliding of 4 kg block. Therefore this 4 kg block will also not slide, and acceleration of 4 kg block will be 0. And this friction which will act on 4 kg block will be equal to the maximum friction, which is also 12 newtons. So this was the answers, and now we move on the next question. In this question you can see that there is friction on both the surfaces, and according to our plan of solving the question, we should find out the maximum possible values of both the frictions. So F max 1 on this surface will be equal to mu mg. Mu is equal to 0.1, and the normal reaction at this surface will be equal to 2g. So 2g will be equal to 20, and this maximum value of friction will be 2 newtons. And this maximum value of friction, F max 2, will be equal to friction 0.1 into this normal reaction, which will be 6G. So 6G will be equal to 60, and it would be 6 newtons. Now this applied force is 12 newton. Now we have to find out the acceleration of this 2 kg and 4 kg block, and we have to also find out the fact that are they moving together or they are sliding on each other. So for finding out this fact and to find out the accelerations, we should follow simple steps. The first step is that to consider them as a system. Step 1 is consider them as a system and find out ACOM. We have to consider them as a system which is moving together, and we have to find out the acceleration of center of mass. If it is a system which is moving together, this one, so this is a system of mass 6 kg, and this force is acting 12 newtons, and the friction which is acting on the system will be 6 newtons, because this friction from the ground is not sufficient to balance 12 newton, so it will act to its full value, and the acceleration of the system ACOM, or A system, we can say that A system, the acceleration of the system will be equal to 6 upon 6, which is 1 meters per second square, which is derived by 12 minus 6 upon 6. So now step 2 is draw a free body diagram of upper block, or in fact of the block on which no force is applied, and you have to draw this free body diagram with respect to the block on which this force is applied. So I'm repeating the step 2, that you have to draw the free body diagram of that block on which no force is applied with respect to that block on which force is applied. So for 2 kg block, if I draw the free body diagram, then there will be a pseudo force which will be acting on this 2 kg block in backward direction, because the acceleration of this 4 kg block is in forward direction, and this pseudo force F pseudo will be equal to MA, and it would be 2 into A which is equal to 1. So pseudo force will be equal to 2 newtons. Now if you can imagine a situation that if we place a block on our hand, and if we move our hand in forward direction with a sudden jerk or with sudden acceleration, then that block will be tending to slip on our hand in backward direction, and this is due to the pseudo force if we analyze that block from our hand frame. So this pseudo force is tending to slip this block of mass 2 kg in backward direction, and the friction which is acting on this block in the forward direction is trying to prevent the sliding. as we all know that this friction always tends to prevent the relative motion. So to prevent this relative motion, this friction will be acting in forward direction, and its maximum possible value that it can apply will be 2 newtons. So it will try its best to prevent this block of sliding, and in trying that, this friction will balance out the pseudo force, and this friction has a maximum value of 2 newton, which is sufficient to balance out this pseudo force, which is also 2 newtons. So we can say that this friction acting between 2 kg and 4 kg will be equal to the maximum friction, which is 2 newton, and there will be no slipping because F pseudo is equal to F max 1. So there will be no slipping because the force of the pseudo force which is trying to slip the block is being balanced by the friction. So there will be no slipping, and these two blocks will move together, and therefore the acceleration of 2 kg and 4 kg will be equal. A of 2 kg is equal to A of 4 kg, and it will be equal to that we have calculated 1 meters per second square. Okay, now we move on the next question. Now in this question we will repeat the same procedure as we have done in the previous one. That first of all we have to consider it as a system, and considering this as a system, the system has a mass of 6 kg, and as there is no friction on the ground, so apart from 12 newton, no external force will be acting on this system. And if you are wondering about this friction, then this friction will be a part in inner force of this complete. This friction will be an inner force of this complete system. So we will not count the internal forces because the acceleration and the momentum of the system is only due to the external forces. So the acceleration of the system ASYS system will be equal to 12 upon 6, which is equal to 2 meters per second square. Now to check whether they are slipping or not, we have to execute our steps. So step 1 which I am executing is the calculation of A system. So A system will be 2 meters per second square, which I have already calculated. Now step 2 is the formation of free body diagram of the block which is not experiencing any external force, and that block which is not experiencing any force is 4 kg. So I am drawing the free body diagram of 4 kg. So there will be a pseudo force acting on the 4 kg in backward direction, F pseudo, and it would be equal to MA, 4 into A is 2. So this is 8 newtons. And to prevent this sliding, because pseudo force is tending to slide the 4 kg, and to prevent this sliding, a friction will be acting in forward direction, and whose maximum possible value F max, which is equal to 0.1 into 20, which is 2 newton. So F max is 2 newton. Now you can easily see that F pseudo, which is a sliding force, 8 newton, is greater than F max, which is a force which prevents the sliding. So the force which is sliding the block is greater than the preventing force. Therefore this 4 kg block will definitely slide, and sliding will occur. Sliding occurs. Now if sliding occurs, then they will not move with same acceleration, and they will move with different accelerations. So we need to execute the third step, which I have not told in the previous problem, but now there is a requirement of step 3. Now step 3 tells that with respect to ground, draw the FBD of blocks and find out their accelerations. Now we also know that if this maximum friction is not sufficient to balance this pseudo force, then it would be acting to its maximum value, and therefore F will be equal to F max, which is 2 Newton. It will not be a self-adjusting force, because sliding is occurring between these blocks and the friction acting will be kinetic, not static. So now with respect to ground, this 2 kg block will be experiencing a force of 12 Newton in forward direction, and as we have already discussed that the friction acting between these two blocks will be maximum, and therefore the maximum friction acting on 2 kg block in backward direction will be 2 Newtons. So its acceleration A of 2 kg will be 12 minus 2 upon 2, which is 5 meters per second square. And if I draw the free body diagram of this 4 kg block, so there will be a friction force acting on the 4 kg in forward direction, which will also be equal to 2 Newton, because action reaction forces are equal. Therefore this 4 kg block is experiencing only this friction, which will move this 4 kg block, and therefore the acceleration of 4 kg block will be equal to 2 upon 4, which is equal to half meters per second square. So you can clearly see that the acceleration of 2 kg block is 5 and acceleration of 4 kg block is half, and therefore this 2 kg block will be moving faster than 4 kg block, and therefore there will be sliding between the two blocks. Now we move on the next question. Now in this question, in which the force is applied on the upper block and there is friction between the blocks and as well as on the ground and the lower block, you have to carefully watch some facts, and you cannot directly apply the steps which we have already discussed here. So in this case, in this special case, you have to check whether the 4 kg block, I am talking about the case in which the force is being applied on the upper block and the friction is present on both surfaces. So in these type of cases, you have to check the maximum value of friction on the lower block on both its surfaces. Now the maximum value of friction between 2 and 4 kg F max here will be equal to 0.1 into 20, which is 2 Newtons. And the maximum possible value of F max here will be equal to 0.1 into 60, which is 6 Newton. Now you can assume that you can see that, you can feel that if this force 12 Newton is applied on 2 kg block on the upper block, then the 4 kg block will move along with 2 kg due to the friction which will be applied by 2 kg on 4 kg. So if 2 kg is moving in forward direction, it would be applying some friction force on 4 kg, and that friction force, which is maximum 2 Newton, will move this 4 kg. But you can also see that the force which will restrict this 4 kg block on the ground is maximum value is equal to 6 Newton. So 4 kg block will not move definitely, because the force which will move the 4 kg block in forward direction is equal to 2 newtons maximum force, and the force which will restrict the 4 kg block is 6 newtons. Therefore 6 newtons is easily 6 newton is sufficiently enough to restrict the 2 newton force, and therefore there will be no requirement of complete 6 newton, and hence the friction force on the ground will be less than maximum friction, and it will be equal to 2 newtons only. So the friction acting on the ground will be 2 newton, and the friction acting between these blocks will be 2 newton also, and the acceleration of 4 kg block will be 0. So conclusively, if in these kind of questions, if F1 max is this one, F1 max, and this is F2 max. If F1 max is greater than F2 max, and the force is being, in fact, F1 max is less than F2 max, and the force is being applied on the upper block, then the lower block will not move at all. Okay. Now if 4 kg block will not move, then we can consider the lower block as ground. So if the lower block is a ground surface, then we can draw the free body diagram of 2 kg block again. This is 2 kg, and this maximum friction will be 2 newtons, and this force 12 newton will be acting on this 2 kg in forward direction, and it is this maximum friction is not at all sufficient to balance this 12 newton, hence it would be acting in the backward direction to its full value, and therefore the acceleration of this 2 kg block will be equal to 12 minus 2 upon 2, which is equal to 5 meters per second square.